Hello Huskies, welcome to the Unit 4 review. Hope you're having a swell fall day. Let's start right off with kind of just summarizing what we've done this unit. Try to see the big picture here. We were trying to find the point where two lines cross. For most of this unit, that's what we were doing. We also called that finding the solution to a system of equations. So finding the point where the two lines cross, we did that by graphing. But then we learned some ways to do it using algebra. So we called it finding the solution to a system of equations when we were kind of doing the algebra. We also called it solving a system of equations. All three of those things mean find the point where these two lines cross. Okay, then we learned some techniques to do that. Like I mentioned, we learned how to solve it, first of all, by graphing. That was the very first thing that we learned. Some of you need to review graphing before this test. The second way that we learned to solve a system was by substitution. That's when we talked about the basketball game, how one variable comes out and everything that it equals goes in instead. And then we took 2 days to learn addition/elimination/combinations. Those all three names mean the same technique. It just depends on what people call it, where they live, what textbook they had growing up, whatever. Okay, after we did all of that, then we graphed an inequality that was with these less than or equal to, greater than or equal to. We found all the solutions. That was the chips and subs. We found an infinite number of solutions, all the possible solutions to a rule. And we showed all those solutions by plotting lots of dots on a graph and then shading. And we had to decide whether the boundary line would have been dotted or solid. And then we graphed a system of inequalities. Notice that this system looks different than the ones that we started talking about in the beginning of the unit because it has inequality signs, not equations. And a system of inequalities is always solved by graphing because we show the solutions by shading, and the solutions are in the region where the shading overlaps, because we would shade for the first inequality, then shade for the second inequality, and they would overlap. And sprinkled into this unit also we had some story problems, but in essence we were just trying to write a system of equations and then solve the system of equations. Okay, let's go. You ready? First of all, on your review you have this handy little chart. There's going to be, the test front page is going to look so much like this. You will absolutely recognize it. Of course, the lines will be in different places, but it's the same kind of setup. So, which two lines have no common solution? In other words, which two lines will never intersect? And I can see by looking at this picture that lines A and B, let's draw, A and B are parallel, so they are never going to cross. And so that's the which two lines have no common solution. Lines that are parallel will never cross, even off the picture. Now, number 2 says, which two lines have the point 4O as the common solution? Don't forget, X comes first and then Y. X is the side-to-side motion, so going to 4, 0 is this point right here, and the two lines that cross at that point are E and F. All right, which line matches the equation y equals 4x minus 6? Well, we're going to have a y-intercept of negative 6, which means we're going on the y-axis to negative 6. That would be right here. And let's just make sure, does it have a slope of 4 over 1? 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. There you go. All those points fit on there. It's line C. And true or false, lines D and E have no solution. Here's D, I'll highlight that one, and then here's E. And right now on my picture, they don't cross, but they're also not parallel. Clearly, if I could zoom out a little bit, they would intersect eventually. And so that's false. They do have a solution. They will eventually cross, like, right there or something. So just because you don't see the intersection doesn't mean it doesn't exist. The only way they don't have a common solution is if they're parallel, like lines C and D. Okay, now for 5 and 7, 5, 6, and 7, I do not want you to solve them. There's not enough room there, and the directions say, tell which method you would use to solve. Explain why, but do not actually solve the system. Okay, so we did homework like this and the classwork like this, where you were just supposed to look at it and tell which one you would do. Well, on number 5, I see an isolated variable. X equals all that stuff. So I would probably replace X with all that stuff, and so therefore I would solve this by substitution. On the test, I ask you to explain why using a complete sentence. So I'm going to model that for you. I would use substitution. Why would I use substitution? Because there is an isolated variable. And that's all you need to tell me. If there's an isolated variable, you would use substitution. Variable. And on the test, it must be a complete sentence. I would use substitution because there is an isolated variable. If they're not complete sentences on the test, I got to subtract a point. I mean, come on now. 9th grade, you got to know how to write a sentence. And I'm trying to do the English favor as a teacher by reinforcing their stuff. So, you know. Okay, number 6. Do you see any isolated variables? No. So then you would solve by, that one is set up so great for elimination. I would solve by elimination because there is not an isolated variable. Now, you guys probably don't need to watch me write all that stuff out. We're going to just move on to the next one. But you get the idea. There is not an isolated variable, ... Okay, hey, look at number 7. I see isolated variable, and therefore I would solve by substitution. If you said solve by graphing on this one, I probably wouldn't mark it super wrong. I mean, they're both isolated, like y equals this and y equals that. But graphing is usually not very fast or accurate, so probably substitution. Okay, now we're actually going to solve these. So let's go. I don't see an isolated variable on number 8. You could isolate one if you wanted to. You could have said y equals 7 minus x. You could have subtracted x from both sides and then solved by substitution. I probably would have done it that way in high school, but since most of you don't like that method, I'm going to multiply this whole top equation by -1. What? Why -1? Why not -6? You could have multiplied by -6 if you wanted to. Don't get trapped with always doing the same variable. I think it will be much easier to eliminate the y's, and so that's why I chose to multiply by -1. Now when I add these together, I'm getting 6x minus 1x is 5x, and y minus 1y is 0. Yay for nothing. And then 2 plus -7 equals -5. Now I just divide both sides by 5, and x equals -1. Okay, I'm half done. I am finding the point where these lines cross, and I only have the x coordinate. It's a -1. So what I'm going to do now is take that -1 and put it back into the original equation, that one, or I could put it in there if I wanted to, doesn't matter which one, and figure out what y is. Well, the first one looks a little simpler to me because there's no coefficients or negatives. So if I replace x with -1, I get that -1 plus y equals 7, and y must equal 8. All right, there is my solution to the system of equations. X is -1, y is 8. All right, number 9, hey, looky there. I have an isolated variable. So I'm going to take y out of the game and replace it with everything that y equals, which is x minus 2. Don't forget to do that using parentheses. Instead of, oh my goodness, whoa. Let's erase that because Mrs. Bagley just messed up big time. I am not replacing x, I am replacing y. So this is just 2x plus x minus 2. equals 5. Wow, almost made a big mistake. Y came out of the game, and what went in is everything that y equals. Okay, 2x, I don't have anything to distribute here. It's like an invisible 1, so I don't really even need the parentheses. Let's see if I can erase those. So what I have here is 2x plus x is 3x minus 2 equals 5. And I'm going to add 2 to both sides. And I get that 3x equals 7. And a lot of you would probably quit right now and be like, I did it wrong. Hey, don't be afraid of fractions. Divide both sides by 3, and x is 7/3. That is not wrong. Just because you get a fraction for your answer doesn't mean you did it wrong. Please don't type that on the calculator and tell me 2.33333 with a little bar on the top. And please definitely don't round off. Leave it as an improper fraction. See that? I didn't even need a calculator. I just divided both sides by 3 and left it. Now I'm going to plug my 7/3 back up into one of the original equations. Since x is 7/3, I'm going to actually stick it into this second equation. And so it's going to say 7/3 minus 2 equals y. And I'm trying to figure out what y is. Well, if you remember from elementary school that instead of 2, I could write that with a lowest common denominator of 3. And 2 is the same as 6/3. So I replaced my 2 with a 6/3. Now 7/3 minus 6/3 is just 1/3. And so that is my y value, and that is the solution for number 9. All right, first page done. Now number 10, there's no number 10 on here. It says, draw a system of equations with a solution of -2, 5. Oh my goodness, the easiest problem on the whole page. On the whole review, probably. There is the point -2, 5. You went -2 in the x direction and 5 in the y direction. Some of you who know you get these points mixed up still, on the test, just be really super careful and double check every time you do a point like that to make sure you went x, then y. These are the positive directions over here. These are the negative directions down here. Okay, I'm still supposed to draw a system of equations with that solution. You can draw any two, oh goodness, any two lines you want that go through that point. There, that's a system of equations with solution of -2, 5. Did I say write the equations? Nope, I didn't. I just said draw. I'll tell you the easiest way to do this one though. X equals -2 would be all this vertical line where all the x's are -2, and y equals 5 would be this horizontal line where all the y's are 5. There you go. That's an equation, a system of equations that has that solution. But again, you could have done any two, there you go, any two lines across there. Number 11, solve the following systems. Okay, we're just more practice. And I think I'm going to solve this particular one by elimination. I'm going to multiply this entire second equation by -3. I chose -3 so that I could end up with a 6x on the top and a -6x on my second equation, and then things will be set up for elimination. Really great. So I'm just recopying this first equation because I like to show my work. And I like it to be clear when I show my work what's happening. So when I multiply this by -3, I'm going to get -6x, -6y, and -6. Do you see something about to happen? I do. When I add this together, I get 0 there, woohoo, and 0 here, and 0 here. Well, happy day. What does that mean when everything adds up to 0? If it adds up to something that does make sense, then, because 0 does equal 0, what happens here is these were actually the same line. And they are touching an infinite number of times because they were one's right on top of the other one. So this one has an infinite number of solutions. They are actually the same line. And that's what happens when either everything goes to 0, or you might at the very end get something like 4 equals 4, something like that. That's an infinite number of solutions. No, I don't want you to write the infinity sign because that's a noun. And in this case, infinite is an adjective. It's describing how many, infinite number. So they're different. Okay, let's do number 12. Well, I have an isolated variable, or 2. So since y equals all that stuff, I'm going to replace y with all that stuff. And that gets me this equation. 3x minus 1 equals 3x plus 5. And so I'm going to subtract 3x from both sides. And I get that negative 1 equals 5. Wait a minute. Negative 1 doesn't equal 5. Where did all my x's go? They added up to be nothing. 0. So since my x's have disappeared and I got something not true out, then the answer here is that there is no solution. Now let's look back at this problem for a second. First of all, that's an abbreviation for no solution. If you went back up here and you solved this by graphing, you inspected it and you noticed, oh, by golly, these two things have the same slope. Look at that. Y equals 3x minus 1. That's a line with a slope of 3. Y equals 3x plus 5 is also a line with a slope of 3. But their y-intercepts were different. And so that means that these two lines were parallel and they will never cross. And of course, that means there's no solution. So look at that. Up here, I just did it solving by graphing. I didn't really even have to graph them, but I kind of used my graphing skills. And then down here in the red, I solved it by algebra, just by substitution, and we realized that they don't have a solution because we got out something that didn't make sense. So look at the difference between 11 and 12 and kind of learn that that's what you do when that happens for each of those. Okay. 13, I'm going to solve this one by elimination because I don't see an isolated variable, do you? I'm going to multiply this whole top equation by positive 2 because I would like to eliminate my y's. And since I already have a positive 2y on the bottom, I would like a negative 2y on the top. So that's going to be really great. And I'm going to rewrite it down here so that I can show my work. I get 6x minus 2y equals 8. Don't forget, when you multiply this equation by something, you're going all the way across the equal sign. Everything in that equation needs to be multiplied by that number. And then I'm going to bring down my second equation and just recopy it underneath so that I can neatly organize my work and make sure that I am not getting lost in a mess of handwriting. Now, 6x plus 2x is 8x. Negative 2y plus 2y, woohoo, that's 0, equals 8 plus 24, which is 32. Well, 8 times something equals 32. Let's divide both sides by 8. And so x equals 4. Awesome. Now remember, you're only half done. You just know that the first coordinate in my point, x, equals 4. And I need to figure out what y equals. So I'm going to put that back up into, let's put it into the second equation, just for fun. So I'm putting this 4 back up into the second equation instead of x. Could I have put it in the first equation? I absolutely could. You would get the same answer. So I'm going to do 2 times 4, because x is 4, plus 2y equals 24. 2 times 4 is 8, plus 2y equals 24. Subtract 8 from both sides, I get that 2y equals 16, so divide both sides by 2, and y must be 8. Okay, I skipped a few steps on that. If you need to work it out using more steps, go ahead, but make sure you can get 8 out for y. And now I've found the solution to that system of equations. Okay, number 14, solve by substitution. So I'm going to substitute x equals all that stuff. I'm going to replace x in the second equation with everything that it equals. 2y minus 5, so 3 times 2y minus 5 plus 2y equals 1. It's so important to use parentheses when you substitute so you can remember to distribute. So now I get to distribute, which is multiplying everything in those parentheses by the number out front. So 3 times 2y is 6y. 3 times negative 5 is negative 15. And then this plus 2y equals 1, that's all just still there. Hey, I have some like terms. 6y plus 2y, that is 8y. Minus 15 equals 1. If I add 15 to both sides, I have now that 8y equals 16. And divide both sides by 8 to tell me that y equals 2. Woohoo! Half done. Here's my coordinate point. This time my second coordinate is 2 because I found y first. And so make sure you're careful about where you put those. It's always x comma y. Doesn't matter which one you find first. The order matters. So I found y first, and that's the second coordinate in my point. Now, since y equals 2, I'm going to come back up probably into this first equation, and now I'm going to substitute 2 instead of y to figure out what x is. So x is going to equal 2 times 2 minus 5. And so 4 minus 5 is negative 1. X must be negative 1. Put that in there, and you're good. There's your coordinate point. All right, a story problem. So many of these are on the test. I bet you're completely thrilled. Number 15, Joe buys 5 notebooks and 3 pens. He spends $10.80. Julia buys 8 notebooks and 3 pens for $15.30. How much is a notebook? How much is a pen? The very first thing I make you do on every story problem is to define your variables and write a system. So let's define the variables, x equals and y equals. It's okay if you use different letters. Maybe you use n instead or p, but do not just use one word to define these. I need you to be very clear. If I say x is notebooks, I don't know if that means how many he bought or what the price was or what they weigh or how many pages are in it. I need to be very specific. I'm telling you right now, if you use only one word to define a variable on the test, you won't get full credit or any credit. More than one word. What are we trying to find? Well, look back up here at your question. It says, how much is a notebook? How much money? I'm looking for the price of a notebook. So in your definition here, you have to have the word price or cost, price of a notebook. And then for y, I'm going to give that define that to be the price of a pen. Okay. Now I know what my variables are because I'm looking for the price of a notebook and the price of a pen. Well, let's write one equation for Joe. Joe buys 5 notebooks and 3 pens for $10.80. How much was one notebook? I don't know. I called it X. So if I bought one notebook, it would be whatever the price of that notebook is. If I bought 2 notebooks, it would be the price times 2. 3 notebooks would be the price times 3. I bought 5 notebooks, so it's going to be the price of a notebook times 5. So X times 5. And then same thing with the pen, so that's going to be 3 times the price of a pen. And he spent $10.80 altogether. Okay, Julia bought 8 notebooks and 3 pens. And she paid $15.30. This is kind of like the problem that we did to introduce solving by elimination, where we're like, hey, look, they kind of bought the same. So what was extra? Well, to help us figure out what was extra, we could multiply this whole top equation by -1. And that would give us a negative there, a negative there, and a negative there. And then the extra would be, oh, she bought 3 extra notebooks. They bought the same amount of pens, and she spent $4.50 extra. That's how much more money Julia spent than Joe. So now we're going to divide both sides by 3, and it turns out that she spent 1.5, which makes more sense if you call that $1.50, because we were finding the price of a notebook. It was $1.50. If your problem is in money, tell me about the answer with money at the end. Don't say 1.5. What does that mean? It's $1.50. That's what the price was. But we're still not finished. We need to find the price of a pen. So you can take that 1.5 and plug it back into x in either one of the equations. I'm going to put it in this first one. You could put it in the other one. It wouldn't be wrong. You would find the same answer. So 5 times the price of a notebook, which is 1.5. And yep, you could say 1.50 if you wanted to. I'm just trying to save room because I'm running out of room. Okay, that says 10.8 right there. And 5 times 1.5 is 7.5 plus 3y equals 10.8. Now I'm going to subtract 7.5 from each side, and that leaves me with 3y equals 3.3. Divide both sides by 3, and you get that y equals 1.1, which would make a lot more sense if you put that 0 on the end and a dollar sign and call that $1.10. And so the price of a pen was $1.10. If I give you a story problem, I would like you to interpret your answer at the end with words. So when I say give me the solution to this, I don't want a coordinate pair this time. I want you to tell me in words, the price of the notebook was $1.50. The price of the pen was $1.10, because that's going to help you make sense of your answer and make sense of the problem. Okay. On to graphing inequalities. Woohoo! We did this probably a different way than a tutor or a parent might tell you to do it. Their way is not wrong, but it's fraught with peril. There are so many places that you can go wrong. My way is safer. So the way that we did this was we said, let's just find the boundary line. And we're going to do that by pretending there is just an equal sign there. I don't want to hear anything about any shortcuts. If you turn that inequality into an equal sign temporarily, then you graph it. You're going to be like, okay, my y-intercept is -7, so I go to -7 and put a point. My slope is the coefficient of x, the number being multiplied by x, and right now that looks like a 2, but I'm going to turn that into a fraction because I like my slopes as a fraction, which would be 2 over 1. So I'm going to go, my change in y is 2 and my change in x is 1. So I'm going to go change in y of 2 and change in x is 1. I'm going to go up 2 over 1. And there's another point, up 2 over 1, point, up 2 over 1. There's my point. And that is my line. Now, should I connect these dots and make a solid line? Well, if we were just graphing y equals 2x minus 7, you totally would. But it wasn't really that. It was really greater than. And since you have a greater than sign and not an equal to sign underneath there, we're going to just leave this as a dotted line. Remember, we learned that in class, that if it's greater than or less than, it's going to be a dotted line. And if it's less than or equal to, greater than or equal to, that's when it's a solid line, because the solutions will actually be on the line. The line is part of the solutions in this situation. Okay, so I have my boundary line. It's just this dotted line. Now I need to know where to shade. Again, don't listen to any shortcuts. Let's choose a point. I'm going to randomly choose 0, 0 because that one is so nice to plug in. So if I'm choosing this point 0, 0, that means that instead of x, I'm going to put a 0. Instead of y, I'm going to put a 0. So I'm going to ask a question, and I put this question mark every time I do this because then you don't get lost. Wait, what am I happening? What? Okay, I'm asking a question. Is 0 greater than 2 times 0 minus 7? Well, I don't know. That's too much for my brain to think about. Let's simplify that. Is 0 greater than, well, 2 times 0 is 0, and 0 minus 7 is -7. Hey, is 0 bigger than -7? Question. Yes, it is. 0 is bigger than -7. So 0, 0 works. And so that means that 0, 0 is a solution, and all his friends and neighbors over here on this side of the line are also solutions. And I could just keep plotting all these points all day long, but it gets pretty boring, and I think you get the idea. And instead of doing this until it's completely filled in and all the solutions are touching, we could just shade and just say, hey, everything on this side of the equation are solutions. These are all solutions. Solution land is on this side of the street. Okay? That's how you graph inequalities. All right, let's do the next one. This time, it's not in slope-intercept form. We like to graph when it says y equals mx plus b. That's what we love. And since our inequality is not set up like that, there's no isolated y, well, we're going to make it have one. And again, when you do this, my strong suggestion is to just drop the inequality, turn it into an equal sign, figure it out, and then at the very end, test a point back into your original inequality. That way, you don't have to worry about, wait, did I divide by a negative? Should I switch the sign around? None of that matters. So, let's isolate the y. We're going to subtract x from both sides. And that leaves me with negative 3y. Don't forget this negative, right? That is a super common mistake to leave that off after you subtract off the x. Now, what is 6 minus x? Well, it's 6 minus x. It's a trick question. That's true, but I really want it to be mx plus b. Remember, we are trying to isolate this and turn it into slope-intercept form. So instead of 6 minus x, I'm going to reverse that and call that negative, or the opposite of x, plus 6. So negative 3y equals the opposite of, I just switched them around, keep the sign with it, you know, if you do that, so that we could have mx plus b. Now I'm going to divide everything by 3, negative 3 actually, because there's a negative in front. So when I divide each term by negative 3, and again, another really common mistake is to not bring the negative with you. Don't forget it. Those pesky negative signs. Negative 3 divided by negative 3 is 1, so that just leaves me with y equals negative x divided by negative 3. Ew, that's not super helpful. What's negative 1 divided by negative 3? That's a positive 1/3. My slope is actually 1/3. Negative divided by negative is a positive, and I kicked the x kind of off to the side so it could be have a coefficient and have a slope and all that. 6 divided by 3, or 6 divided by negative 3 is negative 2. Hey, we're there. We have put this line into slope-intercept form. We're going to go to negative 2 and put a dot. My slope is rise over run, rise 1, and run 3, so that puts me there. Remember that I also could have turned that into 2 negatives. Well, it was that to begin with. I could have gone down 1 over 3 backwards. Remember, this is positive direction, negative direction, negative direction. But see, when I do that, it's still on my line. Oh no, I should check first before I connect the dots. Is it a solid line? No, it isn't. That's only a greater than, so let's not make a solid line to connect those dots. It's a dotted line. My solutions do not include the boundary line. It's like an electric fence. You're going to go right up to it, but not touch it. Now we have to decide, where are we going to shade this thing, top or bottom? Well, let's pick a point. And as always, I like to pick 0, 0 because it just makes the plugging in part so much easier. So where are we putting 0, 0? We're putting it back into our original inequality because that's the one that has the greater than or the less than or the greater than or equal to sign. The inequality tells you where to shade. This equation that we did right here, that tells you the boundary line, and we used that to just find our y equals mx plus b, the boundary line. But the inequality is where we know how to shade this thing, because you have to test it into the thing with an inequality, or there won't be any shading. It would just be a line. So I'm going to plug in 0, 0, and I'm going to remember that I'm asking a question. Is 0 minus 3 times 0 bigger than 6? simplify this thing. It's kind of a mess. Is 0 minus 0, wait, that's 0. Is 0 bigger than 6? Nope. 0 is not bigger than 6. That's not a solution. So that means that all of the solutions are on the other side of the boundary line. And I could just put an infinite number of dots, but to save myself years of time, I'm just going to shade to show that it's all the points over here. Okay. Number 18, I'm going to do this one a little bit faster. You already have two inequalities in slope-intercept form. I'm going to do the top one green, so watch for that. The y is less than or equal to 3x minus 1. I'm going to go to -1 on my y-axis. I'm going to have a slope of 3 over 1, so I'm going to rise 3, run 1, rise 3, run 1, or I could have gone down 3, backwards 1. Now the equal to sign underneath there tells me it's going to be a solid line, so when I connect my dots, I'm going to make it a solid line. That means the solutions could and can be and are part of the boundary line. Now I have to decide where to shade. Well, that's kind of close to 0, 0. I'm going to pick something a little more obvious. I'm going to pick 10, 10. Oh, what is that? 5, 5. Just kidding. 5, 5. So I'm going to plug in this point 5, 5 into my inequality to see if it makes sense. Question. Is 5 less than or equal to 3 times 5 minus 1? Is 5 smaller than 15 minus 1 is 14? Is 5 smaller than 14? Yeah. So that means that was a solution. So I'm going to just shade, oh, hey, my bad. I better do it green. I'm going to shade lightly on this side of the equation. Okay, I'm finished with that first inequality, and I'm going to ignore it. Pretend that's not even there. I'm going to do the second inequality in a different color. So y is greater than -2x plus 4. I'm going to start at 4. My slope is -2 over 1, so I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, and I can see a point where these two lines intersect, but I'm not interested in that anymore. Because these are inequalities, I need to know where the shading overlaps. So looking back at this inequality, I see there's no equal to bar underneath there, which tells me this just needs to be a dotted line. My boundary line is just going to be dotted. It does not equal, the solutions do not equal the stuff on the line. So I just made that into a dotted line. So I have now finished graphing my boundary line. Now let's test a point. I could test 0, 0 this time. It's kind of farther away. It's a little bit more obvious. So my question is 0 greater than -2 times 0 plus 4. Believe it or not, I think this is the trickiest part of these problems because it's hard for students to think about, oh, is 0 bigger than -4? Like, it's abstract and confusing. So what can you do to make this a little bit more real to your brain? You can say things like, let's see, -2 times 0, that's 0. Is 0 bigger than 4? Would I rather have 0 money or $4? Oh, 0 is not bigger than 4. That's not true. So 0, 0 is not a solution. So everything over here where 0, 0 was is not part of solution land for that second equation. It's going to be everything on the other side of my boundary line. Now, notice also that I graphed the boundary line for one and then I shaded. Then I graphed the boundary line for the other one and then I shaded. It gets way too confusing to graph both equations and then try to shade. Graph, then shade, then graph, then shade. Now my answer is where the shading overlaps. And so after you've kind of shaded both directions, you can go back and make that obvious and darker and say, oh, this is the region. These are all my possible solutions. See this stuff in here where the shading overlapped? That's where all of my answers are. Make it very obvious to me. And you might also have noticed that I shaded kind of parallel to the line so that I could see sort of the cross hatching. When I do it in color, it's kind of clear. But if you're doing it at home with pencil, sometimes it's hard to see where the shading overlaps. And so if you shade one direction for one line and then the other direction for the other line, it's kind of easier to see, oh, look, it's where I made plaid. That's the answer. The answer is plaid. Oh, I love fabric, so the answer is always plaid, but you know. Okay, so notice, just want to point this out, you do have a region where only one equation was true, or inequality, and then another region where only one inequality was true. Those aren't part of your solutions. The solutions are only where both of them were true at the same time, where the shading overlapped. Okay, another one. This one's good because it brings up an exception. Here's one of our exceptions. I can't make that look like y equals mx plus b. If I took my inequality out and I just made an equal sign, it would say y equals 3. Well, what does that look like? You guys, if you forget, make a table. Pick some random things for x. X could be -10 or -1 or 0 or 4 or 9. Well, what is y going to be? Y is always 3. All the y's are 3. So if I were going to plot that, all the y's are 3. It's a horizontal line where all the y's are 3. You know, I could have highlighted a couple of those points on here, but it's a horizontal line. So it wasn't actually y equals 3. Looking back, it's y is less than or equal to 3. Well, thankfully, it's a solid line because it has an equal to line underneath there, so I didn't check it before I drew my line. Otherwise, I'd have to erase. But what we have to do now is figure out where to shade. And this is everything less than 3, smaller than 3. Where are the y values that are smaller than 3? Well, they're down here. They're down here. All these y values down here are smaller than 3. That's why I shaded below it. It's less than. Now let's do y is greater than -1. I'm going to put in a slope there. Plus 3. Okay, go up to 3. Hey, my lines intersect there. Don't really care because we're not talking about lines anymore. We're talking inequalities. Now my slope is to go down 1 over 1, down 1 over 1, down 1 over 1. Now before I connect those dots, I'm going to check. Should this be a solid line? Nope. There's no equal to bar. So it's just a dotted line. My boundary line is not part of my set of solutions. And I need to decide where to shade. So I'm going to test a point, and you know it. I'm going to test 0, 0, because I already showed you what it's like when you don't test 0, 0. And why would I test anything else? Oh, by the way, if it's on the line, you can't test it. So if 0, 0 is part of your line, no, you got to test something else. So right now I wonder, is 0 bigger than -0 plus 3? Well, -0 is just 0, and 0 plus 3 is 3. So is 0 bigger than 3? Nope, it's not. So that means we're not shading on the other side of the line where 0, 0 lives. We're shading up here. And my solution set is where the shading overlaps. So that's this region in here, and I'm going to make it super obvious so that anyone looking at my work knows that I know it's this little wedge in here, and technically it goes on forever, but that's where all my solutions are. Now, it says could -2, 2 be a solution to the system that I graphed? I don't know. Let's see. Where's -2, 2? My 0 line is right here. I've sort of shaded on top of it, but -2, 2 is here. And that is a solution to only the first inequality. So it's not a solution to my system because it's not in my super dark region where both of them were true at the same time. So no, it's not in the overlapped section. Explain why not. You know, it's not true for both sides or for both inequalities. Not true for both. So just for fun, I know you don't really have to do this on your review, but let's find a possible solution. A possible solution is going to be a number in this region right here. I'm thinking like 4, 2. 4, 2 would be a definite possible solution because it's in that region right there. It's like, right there. Okay? So that's what it means to be a solution to a system of inequalities. Now, multiple choice. Which set of equations is graphed? Well, let's see. How would I figure that out? I know. I can see a point in this that's my favorite, 0, 0. 0, 0 is part of the solution set for this problem. It's in the part, so it's kind of hard to tell on this because the computer doesn't do it the way that I would like, but I think what's happened here is that the red shading went one direction, like this. Yes, I said one direction. And then the other shading went this way, and then it overlapped in that purple region, this dark region over here. So they only show the answer. I wish they would show all three, but they don't. So anyway, what we know is that 0, 0 is a point in my set of solutions. And so I'm going to test it. I'm going to test a point that I know is in solution land, and I'm going to see what it works in. So for example, let's test it in A. A, I have this system, is negative 2 times 0 minus 3 times 0 smaller than or equal to negative 12. These are all questions. C, 0 plus 0 or 0 minus 0 is 0. Is 0 smaller than negative? No, 0 is bigger. So it's not A because 0, 0 didn't work, and it has to work in both equations. So let's test it into B. It's going to start off looking the same because if you notice, all these equations look the same as far as their numbers go. I just have changed the directions of the inequalities. So this time, let's see, 0 minus 0, is that bigger than negative 12? Ooh, it is. But wait, I have to test it into the second one also because it has to work in both systems. So is 0 minus 0 bigger than 3? Nope. Oh, dang. Thought it was going to be B, but it wasn't. So then you're just going to keep going. So you could probably see here from what we've just done that it doesn't work when it's less than or equal to 12. So look at C. That's what the line on C says. So it's not going to be C because it didn't work when I plugged it into A where it had the same thing. So our answer for this is D. It's going to be greater than or equal to 12 and less than or equal to, greater than or equal to negative 12 and less than or equal to 3. Okay, last page. Two numbers have a sum of 15. One number is 3 less than the other number. What is each number? I know you could guess and check your way out of this, but that's not the point of this problem. Let's define our variables. X and Y are numbers. You can define your variables for this one just really simply. Hey, X and Y are my numbers. Tell me what your variables are. Now, I know that two numbers have a sum of 15. Well, a sum is the answer for when you add things together. So X plus Y equals 15. One number, is it X or Y? I don't know, it doesn't matter, just pick one. So let's say Y is. Y, one number Y is, that's my equal sign, 3 less than the other number. So this is the one where you have to be careful. Is it going to be 3 minus X or is it going to be X minus 3? So model that. If my sister is 3 inches less than my height, then you take my height and you subtract 3. It's not 3 minus my height. It's my height and then minus 3. Just kind of the joke because my sister's actually taller than me, but whatever. It's my height minus 3. So less than the other number means start with the other number, then subtract 3. Hey, let's solve by substitution. Plug that in. X plus X minus 3. I'm leaving the parentheses off because I don't have a coefficient to distribute. And I am going to figure this out that 2x equals 18. So x must be 9. And then the other one must be 6 because they have to add up to 15 or 3 less than that. So 9 minus 3 is 6. So my two numbers are 6 and 9. All right. I love this problem. I just made it up this year. And it's going to illustrate a lot of great things. Dwayne, Dwayne's behind on his homework. He has a lot of catch up to do. Maybe that's going to be some of you over this weekend. I don't know. One week, Dwayne spent 10 hours doing 8 math assignments and 8 geography assignments. Whew. But then the next week, he finished 5 geography assignments and 6 math assignments. That took him 7 hours. So he had a lot of late work to catch up on. How long does it take to do one geography assignment? How long does it take to do one math assignment? Well, I don't know. Let's define our variables. What do you think they should be? I'm thinking if I go back to the question, it said how long did it take him to do one geography and how long did it take him to do one math? I'm going to say X is how long it took to do math. How long to do math? What kind of answer am I expecting here? What is the answer to a question about how long did it take? Oh, it's time. I'm answering this question in time. So when I get my answer back at the very end of this, it better be something that could be a unit of time, right? Negative answers, probably not. It's not taking him a negative amount of time. That doesn't even make sense. We don't go backwards in time. So that kind of is where you're making sense of this problem. All right, let's talk about the first week. Dwayne spent 10 hours. He did 8 math assignments. Well, how long did it take him to do one math assignment? I don't know. We called that X. So how long did it take him to do just the math assignments? Well, since we don't know how long it took him to do one, we're going to have to write an expression. He did 8 of them, and each one took X amount of time. Okay, geography. How long did it take to do one geography assignment? I don't know. He did 8 of them. We called it Y. So 8 times Y would represent how long it took him just on the geography. Now, if we add those two expressions together, we figure out the total amount of time that Dwayne spent doing homework that week. It was 10 hours. Okay, that equation is for our first week. Let's do the next week. What did he do the next week? He finished 5 geography assignments. Okay, well, don't mix these up because geography was Y. So just because I listed it first doesn't mean it has to come first in your expression. And 6 math assignments. 6 math is X. It took him 7 hours. Man, this would be easier if he just stayed caught up. Okay. Hey, what do I have here? A system of equations. I could solve this system of equations. You know, I don't see a number that is going to make this easy. I'm going to have to actually multiply both equations by something. I'm going to multiply my top row by 5 and my bottom row by -8 because I like to have opposite signs, and right now everything is positive. So if I multiply my top row by 5, I'm getting 40x plus 40y equals 50. Multiplying everything times 5 all the way across. Now let's multiply that second equation by -8. So I get -48x minus 8 times 5 is 40y. Oh, good. They're going to add up to 0. That's what I wanted. And -8 times 7 is -56. Add them together. I get -8x right here. My 40s add up to 0, so I've eliminated all the y's. And now I have -6. Well, I'm going to divide both sides by -8. This looks a little crazy. X comes out to be what? 0.75? Does that make sense for this problem? 0.75 what? How long did it take him to do a math assignment? 0.75 hours. Remember how we had in our equation it took him 10 hours total? These are all units of hours. What's 0.75 hours? Well, maybe this would have made sense instead of getting a decimal if I had just reduced my fraction there 3/4 of an hour. What's 3/4 of an hour? Oh, I could have 3/4 of an hour. Yeah, usually we call that 45 minutes. So it takes him 45 minutes to do math. 3/4 of an hour to do one math assignment. That's 45 minutes. That's kind of too long to do a math assignment, but hey, he's behind, so maybe he's last and he has to do a little extra work. How long did it take him to do a geography assignment then? Well, you got to plug that back up inside. And so x is 3/4 or 0.75. So that's 8 times 0.75 plus 8 times y is going to equal 10. And so 8 times 0.75, that's 6. So 6 plus 8y equals 10. Subtract 6 from both sides, and we get that 8y equals, oh my gosh, what just happened? Oh, I went backwards. Okay, I got to write this somewhere else. 8y equals 4. Divide both sides by 8. No, it doesn't take 2 hours to do a geography assignment. It takes half an hour. Divide both sides by 8, 4/8. Oh, does that make sense? 30 minutes to do a geography assignment or half an hour? Sure. Yeah. Okay. We answered the question. It takes him 45 minutes to do a math assignment, which is 0.75 of an hour or 3/4 of an hour, and it takes a half an hour to do geography. Hey, good job. Okay, let's finish up with 6 very quick problems. Write a system of equations with one solution. Well, when I tell you that it's going to have one solution, all I know is that it has to have different slopes. Different slopes will make sure that they will intersect somewhere. So you just write yourself a system that has different slopes. Here we go, 2x plus 3, y equals, 11x minus 7. Are the slopes different? Yes, then it's a system of equations that will have one solution. Am I asking you to find the solution? No, I am not. I don't care what it is. I just know they will have one point where they cross. Number 24, write a system of equations with no solution. No solution means that they are going to have the same slope, but they're parallel lines, and so they have to have different y-intercepts. Otherwise, it'd be the same line. So, different y-intercepts, same slope, different y-intercepts. All right, let's write that. Let's see, I want them to have a slope of 15. I know that's crazy, but it's super steep. Plus 1, and I'm going to say the other one is 15x minus, 8. Okay, all right. They have the same slope. They have different y-intercepts. You pick whatever slope you want, make it the same. Different y-intercepts, those are going to have no solution because they're parallel lines. Okay, a system of equations with infinitely many solutions. That's technically the same line. So what you could do is just make up an equation. X plus y equals 5. And then you could multiply it by something. Let's multiply this whole thing by 2. And then I would get 2x plus 2y, everything by 2, even multiply that by 10. And so since these are actually the same line, because one's just been multiplied by 2, they will have infinitely many solutions because they're the same line. Hey, just before we go on to the last 3 problems, I'm going to talk about your bonus, your secret message. Remember how we discussed that if you have a less than or a greater than, that's a dotted line. And if we're graphing inequalities, which we're not right here on this slide, but this is your secret message. If you have a less than or equal to and a greater than or equal to, that's going to be a solid line. That's your secret message. Write that on the very front of your review, like underneath where it says score, so that I can see it when I'm grading it. And that's your secret message that tells me you have endured 1 hour of this video all the way to the end, and that when you write down this stuff, it'll hopefully help you remember it for the test, but also you can double your score on the review. Okay, don't shut it off just because I gave you the secret message. Let's graph these last 3 for just a quick graphing review. Graphing y equals, this is my favorite line. It's my favorite line. It's so simple, but it's also so confusing for most people because it doesn't look like, what's our goal here? Y equals mx plus b. That's what we like. Well, I don't see anything being added on the end. It's 0. What do I do with that negative sign? Well, that means -1 divided by 1. But if you have a negative slope, that's the same as going down 1, forwards 1, or it's also the same as going up 1 and backwards 1. Just go one negative direction if your slope is negative. So this is going to start at 0 and go down 1 over 1, down 1 over 1, down 1 over 1, or up 1 backwards 1, and connect the dots because it's just an equal sign, and it's just this nice 45-degree angle diagonal. That's my favorite line. I know, it's crazy that I have one, but I do. Okay, x equals 4 for number 27. Wait, that doesn't look anything like y equals mx plus b. This is an exception to the rule. All the x's are 4. Go to where all the x's are 4. Not just one x equals 4. All the x's are 4. Oh, it's a vertical line where all the x's are 4. Okay, and then in that same tone, for number 28, where all the y's are negative 6. Don't just go to one y equals negative 6. All the y's are negative 6. This y is negative 6. And over here, these are all negative 6. All of them are negative 6. It's a horizontal line. Notice that both of these equations, when they're exceptions, only have one variable. There's either an x or a y. If you have an x and a y, like in this one, it's a slanty line. If it's either just an x or just a y, it's a horizontal or a vertical line. I hope you remember those, and good luck on your test.